All right, we have example 2 now. This is a little bit more complex than example 1, but we'll notice that there's one additional step that we'll start out with compared to example 1. And then after we're done with this first step, it's going to be almost identical to that example 1. All right, so the first step that we deal with is simplifying. You should be familiar with simplifying an expression from your previous sections that we've covered in the course. So what we want to do is treat each side of the equation separately and simplify each side of the equation. So we're not going to be utilizing either the addition and subtraction property of equality or the multiplication and division property of equality yet until we have completed simplifying each side of the equation. So let's treat it as two separate problems. So we're going to look at, and I'll circle it just to emphasize this. We have the left side of the equation, and we're going to simplify that completely and treat it as just one single simplifying problem. And then we're going to look at the right side of the equation next and simplify that completely as far as we can. And okay, so let's do that. So the first thing we would do is distribute the 5 to each term inside the parenthesis. So using the distributive property, we would just bring down the 8 minus and then distribute the 5 through, and we would get 10x. And remember that negative is with the 5, so it would be negative 5 times negative 7 is positive 35. Common mistake is they forget to bring the negative through. So it changes the sign of each thing. And so 2x becomes negative 10x, negative 7 becomes positive 35. So it changes the signs because of this negative right here. Remember that. And we're not done simplifying. Again, simplify completely. So we have like terms, 8 and positive 35. So the constants we can combine. And we get negative 10x. And 35 plus 8 is 43. So plus 43. All right, now separately, we can move on to the next side of the equation and simplify the right side of the equation. And so we need to, again, distribute the 3, and we would get 3 times 16 is 48. And 3 times negative 5x is negative 15x. And then we bring down the plus 5. And then, again, we have the constants, like terms. So that would be, I'm going to bring down the negative 15x. And then 48 plus 5 is 53. So it's positive, so plus 53. It's not negative, so it's positive. And so notice that we're just simplifying. So we can actually bring down the equal. So I'm just bringing down that equal to each step. So we're saying the left side of the equation is still equal to the right side of the equation each time we simplify. So notice that now we're in the same form as example 1. We have the variable term plus a constant equals a variable term plus a constant. And that's how example 1 was set up. So pretty much you can just follow what we did in example 1. And that's using the properties mentioned in the previous page. And so first we use the addition and subtraction property to get the variable term on the left side and the constant term on the right side. So if needed, using the addition and subtraction and the multiplication and division properties of equality, I like putting a vertical line. You don't have to do this, but again, it keeps track of, you must do the same thing on both sides of the equation. So we want to move the variable term to the left side. So I'll add 15x, add 15x. Now, I didn't do this in example 1 video, but you can do this. You can do the variable term and the constant term in one step. So if I want so I eliminated the negative 15x by adding 15x to get it on the left side of the equation. But I want to get the 43, the constant term, on the right side of the equation and eliminate the constant term on the left side. So to do that, I would subtract 43. Notice that I did this in one step. I dealt with the variable term and the constant term to get the variable terms on the left side and the constant terms on the right side. So now we are down to negative 10x plus 15x is 5x is equal to negative 53 minus 43 is positive 10. Okay, and at this point we are done with the addition and subtraction property of equality, and now we can deal with the multiplication and division property of equality. So in this case, since the 5 is multiplying by the x, I need to divide by 5 on both sides of the equation to eliminate that coefficient of 5 to just get x equals. And that leaves us with x equals 10 divided by 5 is 2. I didn't mention this in the previous video, but it's always good to check your work. And I'm going to do that here. Okay, to check your work, you take your solution and plug it into the original equation. So I'm going to take x equals 2, my solution, and I'm going to check it by plugging it into the equation 8 minus, I'm just going to write down the original equation to show you that's what I'm doing. And I'm just going to put the 2 in for the x. I'm substituting x equals 2 into the original equation. So I'm going to write everything identical. But I'm going to substitute x with 2. Everything is identical, but wherever you see an x, put 2. So I know to multiply because 2 is being multiplied by x. And 5 is being multiplied by x. Okay, so we simplify. And ideally, we want to have equality. We want it to be equal on both sides of the equation. So let's simplify. So we have to deal with order of operation. And that would give me 4 minus 7 equals 3, 16, and then I need to multiply. So 16 minus 10. And then we still want to simplify inside the parentheses. So it's 8 minus 5, 4 minus 7 is negative 3. That's equal to 16 minus 10 is 6. So that's 3 times 6 plus 5. Negative 5 times negative 3 is 15. So it's 8 plus 15, positive 15, plus 15, equals 3 times 6 is 18, plus 5. And then, as you can see, this will give us 23 on both sides of the equation. So check. So it's not required, but it's good practice. So you may want to go back to example 1 and check to make sure that x equals 3 halves satisfies the original equation 3x minus 5 equals 7x minus 11 back from example 1, and plug it in for x, our solution of 3 halves. And that'll be good practice for you to try this checking method and make sure that it really checks out. All right, let me know if you have any concerns. I'll be more than happy to help.